In this video, I will go over the optimized round in the World Computing Championships. Firstly, let's explain what the optimized round is and its purpose. The optimized round is a round where you are presented with a large question, and you need to write a code for it. However, unlike other questions in other rounds, there is no definitive correct solution. Rather, your code needs to come as close to the best solution possible there is. So, in this round, your code will be tested on multiple test cases, each having a time limit per test and a memory limit per test. And thus, your code may not work for every single test because of these limits. So your aim will be to make it work on as many tests as possible, as that will define how close it is to the best possible solution. You will have to write this code and submit it before a certain deadline, as in this round, you do not have a specific time limit. Rather, you just have to submit your code by a deadline. So now let's take a look at our question called Shuffling the Grid. You are given a two-dimensional grid A of size n by n. Each position in the grid is indexed by a pair of coordinates I and j, such that 1 is less than equal to I and j is less than equal to n. The score of a grid is defined as the sum of aij, so the actual value of a specific element of the grid, times I, so the number of the row it is in, times j, so the number of the column it is in. So the leftmost column would be 1, then 2, then all the way to n. The topmost row would be 1, and then 2, and then all the way to n at the bottom row, over all indices in the grid. So the score of the grid is the value of an element multiplied by its row number and its column number, and added up with all of the other values multiplied by their row number and column number. So now you can choose any permutation p of the integers from 1 to n and apply it on the grid in order to maximize the score of the grid. By applying a permutation on the grid, you can effectively reshuffle the rows and the columns. In particular, if B represents the final grid after applying permutation P, B can be generated by using Bij is equal to API Pj. And what this basically means is, if we look at this sample input, where n is 4, we have 1, 2, 3, 4, 4, 5, 2, 1, 3, 9, 1, 6, and 7, 4, 3, 6. Here, this is the grid initially, before we shuffle it. Now, if we have a permutation, any permutation from 1 to 4, it can be 1, 2, 3, 4, it can be 2, 3, 1, 4, it can be any permutation of 1 to 4, from 1 to n. So since n is 4, from 1 to 4. We can shuffle the rows and the columns using that permutation. So say I get the permutation 3, 2, 1, 4. So what that would do is, first let's look at the rows. It would take the third row and put it at the top. And then it would take the second row, keep it in second. The first row, put it in third, and then the fourth row, keep it in fourth. And then it would do the same with the columns. So the permutation has to be applied to both the rows and the columns. And then it would recalculate the total score, because while the values have stayed the same, the row number and the column number for each value is different. So the sum of all of the total multiplications will be different. So we need to write a code that maximizes this sum for any particular input. And it will run on 10 different tests, ranging from small numbers to numbers as big as 500 for n. So it may not work for all numbers of n. All values of a, I, and j is also positive and at most 500. So firstly, our code will be awarded 3 points per test if it outputs any valid permutation, regardless of whether it is the highest one. And then it will award 7 points for each test if it is the highest one. So for example, if I shuffle this grid and it outputs just any old, and I output any old permutation, but that's not the highest yielding score. That will just give me 3 points for one test. And if it is the highest one, it will give me 7 points. So in total, we can get 100 points as there are 10 tests, and you can get 10 in total for each test. So here's the code that I have written for the shuffling the grid question. This code manages to output the permutation that generates the maximum possible score. However, it does not work for every test case. Since the sample 1 on code forces has only n equals 4, it will work as n is still a small number. So let's test it with n equals 4 with the sample input. So saving the code and running it, and then pasting it here, we'll get 1324, which is essentially the best possible permutation for this input, as this will yield the maximum score for numbers in this grid. The one on code forces said 1, 2, 3, 4, and while that is a viable output, that is not the maximum possible score. So 1, 3, 2, 4 will yield the maximum possible score. So I would get 3 plus 7 equals 10 on this particular test case. So this is how to do the optimized round in the World Computing Championships.